It's Sunday, September 25th. My name is Juan Brown. You're watching the Blanco Lirio channel. And after an uneventful trip to London this weekend, we wake up this morning and find yet another 737 runway overrun, this time in Montpellier, France, where this 1992 Boeing 737-400 freighter converted 737 missed the end of the runway by just that much, 625 feet off the end of the runway, to stop and take a drink here in the reservoir located right off the end of the runway. Let's take a look inside the holes of the Swiss cheese of the threat and error management model, of which investigators will be probing to find out what some of the different links in the chain are that could have possibly led up to this accident. First off, starting with Simon Radecki's Aviation Herald, a Swiftair Boeing 737-400 freighter. Swiftair is a Spanish operator operating out of Madrid. On behalf of West Atlantic, Sweden, registered Echo Charlie November Lima Sierra, performing flight as SWN Flight 5745 from Paris Charles de Gaulle Airport to Montpellier, France, with 3 crew, landed on Montpellier's runway 12 left at 2:36 in the morning, but overran the end of the runway and came to a stop with the nose gear in the water about 650 feet past the end of the runway. There were no injuries. Runway 12 left is 8,530 feet long, about 2,500 meters, and about 150 feet wide. Looking on Google Maps, you can see the runway is located south of town and just right up to the edge. In fact, they used some fill to extend the runway a bit into the reservoir, and it is only about 650 feet, 630 feet or so from the end of the runway to the edge of the water. Preliminary ADS-B data from Flight Radar 24 shows the flight making a straight-in approach to runway 12 left, and investigators will be looking at very closely the data from the aircraft as to the stability of the approach. Was this approach stabilized? And if we zoom into the last little bit of the flight here, right on final, we can see the ground speed varying between 150 and 160 knots, with a vertical speed right in here under 1,000 feet per minute. So this is the indication of a stabilized approach on glide path. But as we get a little closer in, we see the vertical speed begin to increase. There's the vertical speed briefly hits 1,600 feet per minute at 154 knots, indicating to me that the crew indicates to me a decreasing headwind shear, or a bit of a tailwind coming up on the crew at this point. So he's pushing the nose down to stay on the glide slope. That picks up the vertical speed, and in a moment it's going to pick up the ground speed. 158, 161 knots, still at 1,100 feet, still at 1,000 feet per minute. Rate of descent, 168 knots, coming right up to the touchdown point here, very close to the touchdown point, 170 knots, and then he starts backing off on the vertical speed to flare and land the aircraft. In this data that investigators extract from the aircraft, they're also going to find out exactly where on the runway did this aircraft touch down. Did it touch down in the first 1/3 of the runway? Did it touch down in the proper touchdown zone, or did they end up going long before they touched down? Investigators will be looking very closely at the wind readouts. Here's some rough METAR information with the older information down low here. The winds are showing out of 050, so generally out of the east and then the south, east, and then right shortly after the accident, the wind's shifting around from the east to the north, 360 at 21 knots, and then 020 at 19 knots well after the accident. We also see rain showers in the area and overcast conditions. So shifting winds at the time of this accident are going to be a big factor in this accident. Some of the video and picture evidence taken shortly after the incident show pretty good winds on the water at the lake and potential tailwind indicated up here in the trees behind the aircraft. Investigators will be looking very closely at the condition of the runway, what they call runway RCR, or runway condition reading. How wet was the runway? Is the runway grooved? How much water was on the runway? They'll also be looking at the aircraft itself, all the systems on the aircraft. Were all the systems operating normally? Were there any MEL or minimum equipment list items that may have affected the stopping distance of the aircraft. For example, was it dispatched with a TR or thrust reverser locked out? Were all the brakes working normally? They'll be looking carefully at the configuration of the aircraft for landing. Did it have the proper flap setting? What auto brake setting did they use, or did they use max manual braking of the aircraft? They'll also be looking at the lighting for the runway. Were all the lights operational for the runway? Was the crew able to see the entire length of the runway coming in at 2 o'clock in the morning? And that may be one of the biggest factors, in my opinion, with this crash and with these freight operations, is the human factors of fatigue. What was the crew's experience, and what was their crew's schedule and most recent schedule like? With the pilot shortage these days, many crews are working very hard schedules. And with that fatigue comes your ability for decision making. Remember, every landing is a go around with an option to land. If you treat it that way, you can always go around. You can even go around in these jet aircraft after you touch down on the runway, even though the spoilers have automatically deployed. As long as you do not get into reverse thrust, you can still take the aircraft around. Once you pull those thrust reversers out, you're committed. You're committed to land. And finally, looking at this runway at Montpellier, so close to the edge of the water here, this would be a great place for an EMASS system, Engineered Materials Arrestor System, to be built right in here. This is a system of crushable concrete that's being used in a lot of different airports here in the States that will arrest and stop an aircraft that is overrunning the end of the runway with minimum damage to the aircraft and little or no injuries to the passengers and crew. Crushable concrete that stops the aircraft prior to going into the water or whatever obstacle is right off the end of that runway. Even though as pilots we always know we can always go around, tiredness and fatigue, a 2 a.m. arrival, often clouds our judgment, when in the end all we really want to do is get on the ground and get to the hotel. And as we continue to fly these punishing schedules, this is going to continue to be the threat to all of us out there flying the line. Thanks so much for your support, especially the folks over on Patreon that make this content possible. Stay tuned. Next week we're going to get to this Boeing 777 with the sparks on departure. See you here.